let's have a look at this particular body. So let's consider the whole of this block here as a slope, okay, a block that is about to slide off from a slope. And then this side is the rock formation that this material is sliding off, from. And since it's a slope, there must be something we call a tension crack, a crack that should exist, which is causing the separation of this slope from the main or the other material that is intact. And when this has occurred, the tension crack occurs, it creates some kind of space here. And so if your material is not dried enough, you don't take good care of your drainage, water will settle in here, and the water settling in here will exert some kind of force to facilitate the movement of this block. And that kind of force that is being exerted is the vein here. And again, we also have the body wants to slide. It already has got its center of gravity acting downwards, which is the weight of the body, W, okay? And so if we resolve the usual mathematics we do regarding triangles and whatnot, we say that there is a kind of force that is acting, dragging this young man or the block downwards to cause the failure. And when for the failure to occur, the force that it is using is this. And there is also another force acting downwards, which is as a result of the weight of this body. And there is also an opposing force from the block formation here, which is the water pressure, also in this direction, acting downwards, and that is denoted as U here. And as this material is sliding, there will be an opposing factor, which is the R, preventing the movement of this block in that opposite direction. So this is preventing the movement. The R is the resistive force, which is preventing the movement downwards. And you have this. And this here is the usual activities we undertake as geotech, which is a bolt. We may want to prevent this block from moving, and so we put in certain forces, which is bolting or what other knots. And this is the angle, the psi here is the angle of the slope. And this is the angle at which you are putting your bolt. So from this figure, we can compute for your normal stress. The normal stress is denoted as this sigma. And we already have seen this normal stress before. And that can be computed from this, because we said that the normal stress is defined as what? Force per unit area. So the area, the entire area of the block, and then the force that is causing it to move or fail. Then we have the shear strength, and this shear strength, we can pick the whole of this normal stress and put the sigma there. So who can tell us what you see from here? You remember this, tau is equal to C plus sigma tan phi. Do you remember this formula? From what we saw from shear strength. So the shear stress you already have seen before is just in the terms of slope. We say the sigma or the normal stress is rather this W cos psi here. And so this expression is similar to this, which we know from our previous class. And then the resistive force, which is the R we saw, is this man here, the cohesion, the area of the block, plus W cos psi tan phi. This is the resistive force that is occurring. And then we also have the uplift force, which is the pore water pressure that is existing. So this is the pore water pressure, and this is the area that the pressure is occurring. And finally, we have the effect of pore water pressure resisting the force, pore water pressure resisting force, which is also this expression. And so if you have, then it says that when the tension crack is filled up with water, the water pressure increases linearly with a depth, and then the equilibrium block will be. So we are just saying that, assuming I want for us to have an equilibrium where there will be no failure, then the tension crack force that is acting plus the force that is moving downwards. When we saw the figure, there was a force that was acting in this way, and we had another force like this, which was coming from the block like that, and that was denoted as RV. And we had other forces which were opposing it, the resistive forces that are opposing this block, which is the R in that direction, and then the weight of it. Okay, so if we resolve these other forces, I am trying to cause you to fail, and you are also gathering momentum to prevent the failure, which is this one. And so if our forces are equal in the balance, there wouldn't be any failure. So when bolting is used for stabilizing the block sliding along the slope, bolt tension reduces disturbing forces acting down the plane and increases the normal force and friction. And so that is why the bolt was there. Then the factor of safety, F, defines the ratio of the total force available to resist sliding to the total force tending to induce the sliding. So if we denote that in our mind, for us to say that, okay, we are confident that there's not going to be a failure, then we need to look at the force that is resisting failure and the forces that will cause the failure, which is this. If I find the ratio of that and I get, let's say, 1, assuming that is our standard we are going by, that if there is a factor of safety of 1, then we are safe. We can judge that the slope is not going to fail, or we are safe to work. And so that other jurisdictions will say 1.5. I don't know what our geotechnical even say. Those who are too critical will say that 2. So it means that if they calculate the resistive forces, okay, it's just like you trying to calculate whether you go to heaven or hell. Okay, so you calculate the number of good deeds you have done and divide by the number of bad deeds. That is what my teacher used to tell me. So if you want to check whether you make heaven, you calculate your heaven is equal to good deeds over bad deeds. So when you divide and you get less than 1, it means this value here is more than your good deeds, and so you make it to this place. So in the same way, the good deeds here, which is the resistive force, and then the bad deeds here, which is going to cause the failure, is W sine phi plus V minus T cos. And this expression is coming from the bolt you did to avoid the failure. So you are adding some kind of extra components to avoid failure. Then we have, when the slope is stable, the resistive force are greater than the disturbing force. Obviously, we know from the expression.